Hello, and welcome to the live stream of the Kairos 1 rocket, which is being developed by a company called Space One. And this is actually an interesting rocket because it's completely solid fueled, and it's going to be kind of a cheap version of a small sat launcher, which they're developing in order to compete in obviously the small sat market. And just a little bit about myself. My name's Josiah, and I'm an engineer at a group called Astra, and we are a student group which is working in Bremen, and of course we're trying to build rockets. More specifically, we're trying to build a rocket one day which will go to space. So in this endeavor, we of course want to take some of the knowledge from the industry and things like this, and also we're really inspired by these companies which are developing all these new rockets which are going to space these days. So it's good to cover them and get excited and hopefully see some successful launches. So just a little bit of the plan today. We're about an hour away from the launch time. They have a window of opportunity opening at 2 o'clock in the morning UTC, which is exactly 1 hour from now. So that's what we're going to be tracking towards. Because the rocket is solid fueled, you're not going to see a whole lot of fueling and things like this, like you would see in maybe a different type of launch. So don't don't get freaked out if you're not seeing things like vapor clouds and stuff, which indicate that a vehicle is launching. So yeah, better to just keep with what's going on in the commentary, and then we can figure out what's going on that way. Anyways, we're going to be switching over to the live stream pretty soon here. I'm not sure if they are officially live now.
世界最短の打ち上げ時間
Looks
と
like they are.
世界最高の打ち上げ頻度を目指すロケットカイロス。このロケットには時間を超える未来への希望が込められています。美しい海と山々に囲まれた大自然豊かな町。串本町。
As you can see, the broadcast is going to be primarily in Japanese because, of course, it is a Japanese launcher, so that kind of makes sense, right? So I'm going to try to provide a little bit of English commentary of what's going on with this launch and how it's going, what the vehicle's about, what the characteristics of the vehicle are, and a little bit about how the mission profile is going to go, and hopefully a little bit about Space One as well. They are a bit of a mysterious company, so there's not so much that's publicly known, and they definitely have kind of kept their Kairos 1 rocket on the down low. So it's going to be interesting to see how this vehicle performs in the end. So yeah, what is the Kairos 1 vehicle? So just to give you an overall understanding of the vehicle, it's a solid rocket which has 3 stages. So each stage is solid fuel. They're just using a similar fuel combination as to what the space shuttle would have used in its solid fueled engines. So this same formula is being used quite a lot nowadays in the solid fuel market. So each of those 3 stages is going to get it all the way into orbit, and then once it gets into orbit, it has a liquid kick stage at the very top, which allows it to kind of maneuver and eventually deploy payloads and things like that. So that's kind of the vehicle makeup. The idea for the rocket is to try to make this be a low-cost way to get to space, and specifically a low-cost way which is for small sat launchers. Just launching small satellites into orbit. So yeah, it'll be interesting to see whether they're actually able to achieve that goal successfully. They have some big ideas about how many things they want to be launching in the future. They want to get a launch cadence up to 20 rockets per year. So that's definitely going to be an impressive rate if they're able to actually successfully get to that number. But it all starts right here. So we'll see if they're actually able to realize this vision now, of course, because this is where they have to kind of make things happen. Yeah, so I think that a lot of the initial stuff here is going to be in Japanese, so maybe we can kind of... The launch site looks really nice, by the way. It's in kind of a really cool location. I can kind of show you where that is. So, of course, this is a Japanese rocket, so it's launching from Japan. And it kind of launches, I think it's just south of Kyoto, and it's down by the coast. And, of course, that's how they're going to be launching towards the east. Japan's really a great country for launching rockets because they have a bunch of ocean, which is out to the east. So that's kind of a a little secret tip as to why Japan makes for great launch sites. So yeah, that's the location they're going to be launching from. We're looking forward to seeing some blue skies, and hopefully they have some nice tracking cameras which will be able to follow the rocket as it flies. I'm not sure if they're going to be carrying any sort of cameras on the upper stages. Just to give you a heads up, usually on these types of launches, they tend to just have like an animation or something like that for the later stages of the flight. So don't get too disturbed if they don't have, SpaceX quality cameras on the rocket. It is a very small vehicle with a payload capacity of only 150 kilograms to sun synchronous orbit and 250 kilograms to LEO. So even just adding a camera actually does drastically reduce their payload capacity. So I can kind of understand for vehicles like this why they might be a little reluctant to cut into their payload capacity with these types of things. Yeah, sometimes they will have like more of a live view into the mission room, and you'll be able to see some telemetry that they might be showing. So yeah, we'll see what kind of a live stream these guys do. Again, very mysterious company. I'm not really sure exactly how they will do these things. This is their first live stream of a rocket launch. It's their very first rocket launch overall. So hopefully they are up with the modern trends of trying to give the audience or the world a deeper insight as to what's happening with their vehicle. Yeah, great to see that people are joining from the US. Yeah, always good to see what kind of other launches and what other launches there are around the world, not just in America. Yeah, maybe they're gonna turn a new leaf and be that interesting company that actually gives a very high quality cameras on their upper stages. We'll see. Yeah, if you ever want to be a hit with people in the world, I think that's kind of the strategy to go with in terms of sharing what's going on with the rocket. Rockets are awesome, so we should try to share as much as possible that goes on with them. But yeah, these private companies are often quite reluctant to share so much data at the very start because, if the rocket blows up or something, then they don't want that to be like, publicized everywhere with all of the telemetry data as well. Oftentimes these companies are publicly traded, or maybe they have investments tied up with government contracts and things like this, so they don't want to look bad to a public audience. But us being rocket enthusiasts, we do know that rockets have a tendency to be complicated, so we don't really judge so quickly if it's just the first launch. Yeah, it's not like it's an invisible deployment, that's true. You can always track things. Everything gets tracked when it goes to orbit, so oftentimes, even when it's a classified payload, if you're a clever tracking professional, you can easily find the things that get launched just by looking at their trajectory and stuff. I don't think this one is super secret and that you're not allowed to know which orbit it goes into, but the payload itself is a little bit on the down low, so to say, because it is being launched for the Japanese intelligence agency. You watch the Apollo launches and recoveries, like it live in person, because that I'm definitely jealous of. I wish that we were, that kind of stuff was happening live. That would be. Sometimes I wish I was born earlier, because then I would be able to see those things live. But we have some cool stuff that's going on today too. There's all kinds of rocket development, and who knows? Maybe we'll be seeing some Apollo-style launches in the future. It looks like the world is swinging that way quite quickly. Yeah, Ty, it's definitely the case that launching to space is hard. That is 100% the case. And I think the thing that's the hardest is, like, getting to space is not so hard. I mean, if you just go straight up and come back down. It's getting into orbit that's really the sauce, And there's only a couple of companies that have actually been able to do it. At this point, I think the first one was SpaceX. Then you had Electron, and then there was Astra Space, and Relativity did Relativity do it? No, their rocket didn't make it. I think Firefly Aerospace, they made it. Virgin Orbit also made it, but they're out of business now, so they kind of don't count anymore. So it's just like a handful of companies that have actually been able to make it to orbit. So it's a very exclusive club if they're able to pull this launch off. And I actually believe that there's not a single rocket that's ever made it on the first try. So if they're able to pull this launch off, they can one-up all of those previous companies. Yes, I will do my best to try to I can't speak Japanese, so I won't be able to translate what they say, but I can try to give an English commentary to what's happening with this Japanese rocket. So yeah, right now I have no idea what they're saying, but I imagine they're doing some public relations and trying to put a context behind why this launch is so important. Right now, Japan actually has a lot of different launch vehicles. They just launched the H3 rocket about a month ago, and that was successful on its second try. Although technically its first try, it was the first try they had a bit of a igniter issue, and then so they didn't actually take off. So technically the second try was still the first try. So if they are able to also get this rocket, the Kairos 1, online, that's two rockets that are new, that are now available to the Japanese launch market. So that's pretty cool. Usually smaller countries that are not America will not have multiple launch vehicles available to them. But yeah, that could be a new thing for Japan. What rockets are we working on? So yeah, we just finished working on a rocket which we called Karma. But unfortunately it didn't get to launch because we didn't get all of the integration done in time for the launch date. But now we are kind of redesigning, and we're starting a rocket which is called Karma 2. And this one is hopefully going to be the one which will get to launch. We're going to try to launch again at EUROC, which is the European Rocketry Challenge, which is a lot of student groups go and they launch at this competition in Portugal. That's going to be happening in October 2024, so in about 6 months or so. So yeah, that's the rocket that we're primarily developing right now. However, we're also looking forward into the future, one more year, and we'll probably start developing our Transcendence rocket, which is the one that we're planning, which will go to space. So probably in the later part of this year, we'll also start working on that as well. But yeah, the exciting stuff for us though is that we're going to be doing some propulsion testing again in May, and it's going to be a really exciting one because the rocket is quite a powerful one. We're trying to get one up to around 8 kilonewtons, so it's definitely going to pack some serious punch. And it's going to be the most powerful engine that we've developed so far. So hopefully it goes successfully. It looks like they are intriguing over the ability to communicate with each other over the big screens. Yeah, the motors that we're using for Karma are not solids; they are actually hybrids. So we use nitrous oxide as our oxidizer and paraffin wax as our fuel. So this is more of a safety thing. It's very hard to do solid rockets, which are powerful in Europe, because you have to like get permission to be able to work with solids. So naturally, you usually end up defaulting to more of either a hybrid or a liquid solution. So pretty much most of the rockets that are developed in Europe are those two options. And right now, we don't really have a lot of money, so the liquid option is not really available to us. So we've been basically just developing hybrid rockets at this point. Maybe in the future we'll start looking into doing a liquid, but that would require us to have a little more funding underneath us to be able to afford the technology that goes into that. Yeah, the hybrid that we develop is all pressure fed, so it's just nitrous oxide, which is contained at around 55 bar. And then because it can be autogenously pressurized, you can use that effect to basically push the liquid nitrous oxide into the combustion chamber. Yeah, so we'll be testing that again in May. We did 2 tests last year, 2 testing campaigns, and in the end we hot fired like I think 10 or 12 times, somewhere in there. Only one which was fully successful. So we learned a lot in the whole process. And we're hoping we're going to get some more successful hot fires coming in May. Yeah, liquid propellants are definitely more complicated to work with. If you get them right, they're more fun. When they're not behaving the way you want them to, then they can be less fun. Yeah. But yeah, obviously Space One also has the understanding that liquids are quite complicated, and they are of course making the Kairos rocket with just solids. So maybe there's something that they understand about this that maybe we're not totally understanding ourselves. what always gets me is I wonder like how hard it is to actually control a solid rocket. So like if you want to have a specific trajectory, like obviously if you want to get to orbit, you have to follow a specific trajectory. The only way to do that is to somehow vector your thrust so you can control the vehicle. Like it's not like these rockets have fins or anything to use. So yeah, it's tough to use solids unless you have some pretty sophisticated methods when you're dealing with orbital spaceflight. Yeah, turbo pumps are pressure fed. Well, again, going back to the broke stuff, we can't afford a turbo pump. It would be wonderful if we could, because then we could obviously pressurize our tank to a much lower pressure and then save a lot of mass. But yeah, unfortunately, everything that we build is pressure fed. So we build these we build tanks that can handle the pressure that we're dealing with. So it's basically just a metal liner that we overwrap with CFRP. We've gotten actually quite good at wrapping the CFRP, so yeah. This year we're looking forward to potentially even increasing the efficiency of our tanks and cutting some mass. That's one development that we're currently engaged in. We're trying to switch to an aluminum liner instead of using steel, so we're going to cut some pretty serious mass by doing that, which should hopefully make our rocket a little more efficient. Yeah, I agree. We definitely need some more funding for rockets. But you know, it's not like it's not there. There's like, 30 or so rocket groups which are currently active right now in Europe. So clearly the interest is there, and there is a little bit of grassroots development that's happening. But yeah, it's nowhere near as mature as the amateur rocket community in America, I would say. What we really need is more places where we can launch high power rockets. Like there's lots of altitude restrictions all over Europe, and it's very difficult to find a place where you can actually even do these activities or test rockets and stuff like this. So you always end up having to go really far away and spending lots of money, and then things just end up getting more expensive that way. Yeah, for those just joining, we are here looking forward to watching the live stream of the Kairos 1 rocket. It might not look like it when you're looking at the live stream right now, but this is the stream for a rocket launch. We're just about 40 minutes away from the start of the launch window. They do have a 1 hour launch window, so they could start any time from 40 minutes from now to an hour after that. This is a maiden launch of the Kairos 1, so this is the first time that it's coming to the launch site, and it's going to be their first attempt to try to achieve an orbital launch. So this is an orbital launch vehicle. The vehicle is entirely a solid rocket, so it all of its 3 stages that it's made out of are all solid fuel. There is a liquid fuel kick stage, which helps it get the payloads into their correct orbits and such. But the main energy of the rocket is coming from solid motors. So this vehicle is being developed by Space One, which is a new company in Japan. This is going to be a new launcher that's going to be able to launch payloads from all around the world. It's going to be totally a public launcher, which anyone can, of course, go and hopefully use. They want to ramp up the launch rate from right now 0 all the way up to around 20 launches per year, and they're looking to get up to that rate in the next couple of years. So it's really important that they nail this rocket launch and get it working well so that they're able to achieve that vision. And yeah, it's good to see that there's more small sat launchers around. There obviously needs to be some more competition. Right now, I think the main competitor right now in that area is just the Rocket Lab's Electron rocket. It kind of has a chokehold on the market, I would say. If you want to launch a small satellite, they're pretty much the one to go to, unless you're going to go do a rideshare. So right now the Electron vehicle costs around, I think, $7.5 million. So That's kind of like the benchmark. The sticker price for this one, the Kairos one, which is the one that's going to be launching today, is 9 million. So it is on the same like level as the Electron in terms of pricing. The Electron is a little bit more, can perform a little bit better. It can get slightly more payload into orbit. So I think the Electron does 300 kilograms, and this one does 250. So again, they're competing in kind of the same area. So it'll be interesting to see which one comes out on top. Although on the surface of things, it seems like the way that Kairos 1 could compete is more on the reliability side and maybe the quick cadence of launch. So if they can easily service customers in a quick time frame, maybe they're willing to pay a little bit more in order to get that I don't know, functionality. Yeah, you really like to get involved in rocket engineering. Well, to be honest, it doesn't take much. All it takes is a little bit of tinkering, I guess, and you can get into it. There's lots of ways you can get into building amateur rockets at varying cost levels. At the very start, if you're just dealing with little motors, you can definitely start tinkering a little bit, and then maybe if you start self building some stuff, things start getting a little more expensive and a little more challenging. But I mean, if you have a little bit of time and a little bit of cash, yeah, of course. Anyone can get involved in rocket engineering, I would say. Yeah. If you want to go straight into the high power stuff like Astra did, feel free to peruse our channel. We've tried to post all the different ways that we've tried to I don't know, cheat the system and try to design things in a more cost-effective way. A lot of those things are sometimes not quite as good as they seem, so yeah. But it's maybe interesting to see the process that we went through in order to design our first rockets anyway. Yeah, we have some cool stuff that's coming up. Some new innovative ideas about how we're trying to, I don't know, solve the problems that we had last year. And so, yeah, it'll be interesting to see how those come into fruition. That'll really be put to the test in May when we do our propulsion test. This is actually a view of the launch site there at the start where you saw the sunrise. It's really a beautiful location that they have here. It's right on obviously it's right on the ocean. That's usually where you put a launch site. But it's also like in the kind of hilly mountainous region in Japan, and so they have lots of nice nature around. Yeah, I can imagine that it would be quite an interesting place to work. It looks like we lost sound. Interesting. Okay. Well, enjoy the marketing for vacationing in Japan. So for those just joining, we are now just over 30 minutes away from the launch of the Kairos 1. This is a new rocket that's being developed in Japan by Space One, which is a new company, and they're looking to develop small satellite launchers, and this is, of course, a small satellite launcher. It has a payload capacity of 250 kilograms to low Earth orbit, so it's definitely one of the smallest rockets that is out there. The only rocket that had a payload smaller than that was Astra's rocket, which that would be Astra's Rocket 3 vehicle, which did get to orbit a couple of times, but probably most famously didn't get to orbit more times than it did. So yeah, they had some difficulty with making that system work themselves. But that was a liquid rocket, and this is a solid rocket. The Kairos 1 is a solid rocket, so potentially it's a little bit simpler than some of the other small satellite launchers that are out there. I think most of the small satellite launchers right now are liquids. Like the Electron is also a liquid rocket. And Firefly is also a liquid rocket. Relativities was a liquid rocket. They're all liquid rockets. So maybe there's something to be said for the solid rockets. Maybe they can do it for cheaper in the end. Although right now, based on the sticker price of the Electron and the Kairos 1, it looks like the Kairos 1 is still slightly more expensive. But I suspect that maybe that will change in the future, because if Space One is actually able to scale up their vehicle development and scale up the launches that they're actually doing, then potentially they could easily sell them for a lot cheaper. But yeah, we'll see. Right now they're launching a payload which is for the Japanese intelligence agency. So I think it's clear what their initial objectives are, which is to obviously give Japan more opportunities to launch payloads into space. So I'm sure that will also work for them. And obviously, being a solid rocket, they might also have some more capabilities to like rapidly service customers. So they could come with a request, and they could probably pretty quickly get a vehicle ready to actually fly. So that could be another positive. Yeah, I'm getting a little bit of a taste of Japanese culture here. The entire broadcast will be in Japanese, so I'm going to try to give some English commentary along the way. Hopefully they're eventually going to cut to a live view of the rocket. Obviously there's no fueling activities that are happening, so maybe it's not so interesting of a view, but yeah, it's a solid rocket, so there's not going to be any like vapor clouds or fueling activities or anything that would be related to that. But yeah, we're really getting an introduction here to Japanese culture. Even looking at the different industries that exist in Japan, not just the rocket one. Although something can be said for how sophisticated the Japanese rocket industry actually is. They do have multiple different vehicles which are targeting to be able to launch into space, and they have a rich history of developing different systems and developing those systems quite successfully. Yeah, really quite impressive for not really a little country. I mean, they have like 100 million people, but yeah. I come from Germany, and Germany still doesn't have a launcher, so unless you count the Ariane 5, but it's kind of like a group vehicle between all of the European countries, and more French than anything. Yeah, I would like them to switch over to a view of the launch site or the vehicle. I think that would be nice to see. But you do get to see an animation of the rocket on their big screen there. Just to give you an idea of the size, the height of the vehicle is about 18 meters tall, and the width is 1.35 meters wide. So it isn't even really that big. If you compared that to like an amateur rocket, the rocket that we are going to build that will go to space is going to be about half as tall. So if you really think about that, it's almost like a student group is almost in the building things of the same size or similar sizes as to these small sat launchers, which really tells you something about how efficient these small sat launchers really are, because obviously the student rockets are not going to be able to get to orbit, but yeah, with not so much size, you can definitely do a lot. Yeah, Germany did have the V2, but that wasn't really an orbital launcher. It was more of a suborbital launcher. Yeah, which more of a missile than anything. Yeah. Now Germany doesn't even have the V2, so that they don't even have suborbital capability anymore. Yeah, Germany is, I would say, lagging a bit behind in the whole space industry. Where Japan excels, yeah, Germany a little bit behind. But we do have some development that's coming soon. There are now 3 companies in Germany which are trying to develop small satellite launchers. There's a company called Rocket Factory Augsburg, which is like a subsidiary of OHB, which is like a satellite manufacturer. They're developing a rocket which will be able to do about 1 ton to low Earth orbit. Uh, they just successfully last year had a full duration burn of their second stage engine, which is kind of a big deal. They were very excited about it. So they're one step closer to hopefully getting to getting a rocket into space. That being said, they have been saying they're launching next year for the last 5 years. So take what they say with a grain of salt. Yeah, there's another company called High Impulse. They're actually kind of a cool company because they formed out of a rocket group which exists in Stuttgart. There's a group there called High End, and the original people who were at High End and developing rockets there, uh, after they built the European record-breaking rocket, they just kind of decided, oh, let's form a company. And so they formed a company, and that's called High Impulse. Yeah, so they're also developing a small sat launcher, but instead of doing, solids or liquids, which are kind of the ways you usually get to space, they're trying to develop a hybrid, which will go to space. So, High Impulse doing something completely different than everyone else, and who knows, maybe that's going to be the way to get to space cheaper. I'm a little skeptical, but hey, maybe they got something we don't know. Yeah, they're not going to use nitrous oxide though. They're going to use liquid oxygen and paraffin wax. So yeah, we'll see how it goes. Then there's one more company in Germany. I'm forgetting the name of it. It's based in Munich. They're also developing a small sat launcher. I'm not really so sure about their progress. I'm not totally in the know of their group. The other 2 groups, we have lots of connections to. Rocket Factory Augsburg, there's lots of Astra members who actually work there. So obviously I know a little bit of what's going on there. And then of course we're connected with the High End group. We talk to them a lot. So from them, we actually know a lot about High Impulse as well. We also see all these companies at the fairs and at the expos and stuff. So yeah, I hope that one of them gets to space by 2025. I think that would be really exciting. And then finally, Germany can be in the rocket business. Who knows? Maybe one day we'll be competing with the likes of Japan. But for now, not so much. So I'm kind of curious when they're going to cut to the start looking at the rocket and maybe talking about the rocket. For that, right now, it just seems like they're talking more corporately and discussing about. Well, I really have no idea. I don't speak Japanese. But I have to say that the Japanese definitely have a different flavor to their live streams. It's definitely less technical and more experiential, shall I say? But it's kind of cool how they're just outside, like they're just outside doing a live cast. I assume that they're able to see the launch site from where they are. Although we haven't really seen a camera which has turned around to see the launch vehicle. And I'm hoping that they also have a good ground live tracking camera. But we'll see. We'll see what they got. And maybe they might show us some of the mission room. I don't know. One thing that's interesting about the small sat launch market right now is that there's dozens of companies which are developing them. So the real question will come in about 5 years, which is which vehicles will survive. Obviously, not all of them can exist in the same market and thrive because, well, there's not so many small sats satellites that need to be launched. So it's really going to be critical who ends up soaking up that market share. And whoever gets their rockets working first is kind of going to be the ones that make it. So that's why I'm a little bit worried about the German launch vehicles, is because they're kind of late to the party. Yeah, that's exactly the right name. Izar Aerospace, that's the one. Yeah, sorry, I forgot the name. I shouldn't forget. I see them all the time. I shouldn't forget their name. Yeah, they're also developing a small sat launcher. Yeah, we'll see if they're able to get there as well. I'm not so up to date on Izar Aerospace, but a year ago I was kind of most confident in their development, but I'm not sure about that now. Rocket Factory Augsburg also has some good progress, so it might be a race between them. Yeah, there were no views of the launch pad yet. Don't worry, you haven't missed anything. As far as I could tell, there was nothing that they've shown yet. But it'll be interesting to see if when they decide to show that stuff. I mean, we're getting pretty close to launch here. It's just over 20 minutes away. So I imagine they definitely already have the rocket out there. I mean, so come on, they got to show it off. This is what we're all here to see, right? Yeah, it's not such a big rocket, but hey, it should still be shown off. What I think Germany is missing right now, though, is we do have these three companies which are developing small sat launchers. But what would really be interesting would be a company that just decides to go straight and start building like a big rocket, like a rocket which can compete with the Ariane 6, which is the new one that Ariane is developing. I think that if Germany decided to go for that, I think that would be a really smart move. Because right now there's not a whole lot of vehicles that are in the heavy lift market. Obviously, SpaceX kind of outcompeted everyone. So I think there's kind of a market gap right now for potentially having a vehicle which can compete with the likes of SpaceX. And right now, there's not really any company that's really willing to do that. So I think there's going to be a big reward for a company that just is ready to just put their chips down, spend a bunch of money, and develop a system that can actually compete with SpaceX's vehicles. Yeah, Vulcan is kind of operational. Yeah. I don't know. Like yeah, right now the Ariane 6 is supposed to come this year. It should be ready this year. But the problem is it's the same problem as the Vulcan, right? It's going to be way more expensive. Yeah, I just don't think that's United Launch Alliance or Ariane Space are going to be able to compete with SpaceX's prices. Like, they can't even compete with the Falcon 9 right now, really. Let's be honest. Like, Falcon 9 will still outcompete them. Imagine when they get Starship operational. Like, it's just no chance. You need to have a fully reusable system. It's the only way you can compete realistically in the market 2 to 3 years from now as a heavy launch vehicle. That's just the reality. So I think that companies have to think about that, and they need to really start thinking about developing in a direction where they're going fully reusable. Because because they gotta bring those costs down. Otherwise, SpaceX won't even lower their cost. SpaceX will always just lower their cost just enough so that they can outcompete everybody, and they'll just pocket all the money. So they needed somebody to really compete with them, to really keep forcing those prices to come down. Yeah. It's kind of weird that reusability is still not a feature of these new vehicles, which are coming online. You know. Yeah, that's exactly the case. Basically, if you're not doing reusability, you're just not relevant in the heavy lift market. It's just the case. The only way that these companies can still stay afloat is because they launch dedicated payloads for like the military of their country. So United Launch Alliance can stay alive because, well, the Department of Defense does give them contracts, and they will always do that because, well, they need to try to keep the launch market competitive. That's like the justification, so that they can still stay in business. And it's kind of the same thing for Arianespace. The European community has military type stuff that it goes up to, and also, you know, local content. So maybe some satellites that are being developed in Europe, they want to, you know, they don't get funding unless they're going to launch on a European vehicle. That's why Arianespace can stay in business. But yeah, I guess there's also SLS. That's true. But I think SLS is not even really in the conversation in terms of cost effectiveness. I don't think anyone in their right mind would ever contract an SLS to do anything, except for NASA, I guess, because, well, they got to get people into space and to the moon. But it's definitely not a vehicle that's used to get payload into orbit. It's just not a vehicle that's competitive. Yeah, SLS could have been so much more, but I feel like it was just plagued by the age-old question, the like that. Oh, we will just not change anything and, you know, keep all the old stuff, and just that's going to be the way it's cheaper. But, you know, if you do that, you never really get things to be cheaper because you're still carrying over all the old technology, and you're not really updating the things for what's going on now in the industry. Yeah, I mean, I feel like NASA kind of burnt their hands with the space shuttle, and now they just kind of had the feeling like, oh, reusability is not worth it. What they really should have done is kind of they should have taken all the knowledge they had from the space shuttle and just made it better. Make reusability work better. I think they had that capacity. Ah, the launch site. There it is. There's the rocket. Standing proudly on the launch pad. We've been waiting for this. Okay. Yes, the rocket does exist. It is there. And they even have the clock there. You can see that we're counting down from 16 minutes now. Yes. So we're 16 minutes away from launch. They do have a launch window, so it's not like it's instantaneous. They have an hour, which they have cleared with the airspace regulators. But I think they'll try to go for that initial launch window. I mean, it's a solid rocket, so basically you just hit the button and go, right? Yeah, no, you don't usually have fins for guidance on orbital rockets, right? Like usually you vector the thrust, which is the way that this rocket will work, I assume. Again, no public release on the data, but that's the only really way they could do it, right? If they don't have fins. I don't think any orbital rockets have ever had fins. That's not really it works great when you're in the atmosphere, but then when you're out of the atmosphere, you still need to be able to like maneuver, like for the upper two stages. So yeah, having fins doesn't really work then. Yeah. like and the weird thing is like I understand the concept of vectoring thrust for a solid rocket, but like the actually building the system that does that just seems so like insane to me. This is a bit of a cool location because you can see how it's like the launch site's kind of in a valley there. So they're basically going to launch like through the mountains, through the valley, towards the ocean. That's the plan today. Yeah, and I somehow highly doubt they have a camera on that vehicle. But yeah, hopefully they give us at least they have a tracking. I hope they at least have a tracking camera. We can see it for a little bit. One thing that's a little bit concerning to me about the vehicle design in general is the nose cone fairing, which is actually quite small. Like if you compare it to the Electron has a 1.8 meter diameter payload fairing, but this one actually only has a diameter of 1.5 meters, so it's quite a bit narrower. I wonder if that's going to hurt them in terms of payload capacity and stuff like this, but we'll see. So after Astra's Flight 3, it's important to leave horizontal space in the rocket to also open the gate. Yeah, if you remember Astra's flight, they ended up like going sideways at the start because they lost one of their engines at the very start, and their rocket had exactly, I think, 1.2 or 1.25 thrust to weight ratio. So when they lost one engine, they were at exactly 1.0 thrust to weight ratio. So basically, it didn't go up at all and just started just going sideways, which is an interesting failure and definitely a unique situation that occurred there. Yeah, definitely my favorite failure that occurred. Unfortunately, this can't happen with a solid rocket. Like either it works or it doesn't. So if they lose the engine, then it just doesn't go anywhere. Yeah. If it hits the gate, then there's probably bigger problems that are going on. Yeah, I wonder when Astra Space is going to get their next rocket going. Because they do have they are developing a new rocket, which is Rocket 4. It's supposed to replace the Rocket 3, which was notoriously not so reliable. And it's going to have a bit more payload capacity. And will also, I mean, on paper, it is supposed to be the cheapest rocket out of all of them. But yeah, it seems that the development is kind of stalled, and they're definitely struggling financially right now. So we'll see if they're able to actually turn it around and maybe get another launch. So now we're just 11 minutes away from launch. For those joining new, this is a Japanese launch vehicle. It's called the Kairos. Kairos? Yeah, it's called Kairos. It's made by Space One, which is a new company in Japan, which is developing a small sat launcher. Yeah, the stream is obviously in Japanese because this is a Japanese rocket. So I'm here to provide a little bit of English commentary. So if you're interested in seeing this rocket fly, but don't understand any Japanese, and maybe want to hear some English, then you're in the right place. Just to again go over the specifications of the rocket, it is a solid rocket. It has 3 stages, so there's 3 rockets in one rocket, kind of, and it's going to use those 3 stages to get all the way into orbit. There's also a kick stage at the top, which is used to kind of give it a little extra juice so it can get into the final orbit, and also to maneuver and deploy payloads and stuff. I suspect today we'll be seeing a live view of the launch, and I hope they have a tracking camera, so we'll be able to follow it probably through until the finish of the first stage. After that, I suspect we probably won't get a live view from the rocket. I could be wrong about that, so you never know. But yeah, basically the rocket's flying directly east from its launch location, which is putting it into I think a 33-degree inclination orbit. So yeah, if you're curious about the orbital insertion characteristics that it will have. The payload is a Japanese intelligence satellite, so it's a little bit secret. And I think this is actually a market that Space One is trying to chase, which is, of course, one that is secure in Japan anyway. Yeah, we're just, as you can see the clock, it's on the top right hand of the screen. We are just under 9 minutes away from launch, so we're getting quite close now. So definitely don't run away at this point. It's also looking like the announcers are getting a bit more excited, so that's good to see. And they are finally showing us the view of the launch pad, so that's nice. I wonder if they're going to also have the countdown that they usually have. Like, I know at the launch site for the H3, so like that's the official Japanese like Space Center launch site. They usually start their countdown at like 5 minutes before the launch. And it's just like this lady counting down for 5 minutes until the rocket launches, which I think kind of gives a little bit of extra suspense. And gives it a little bit of a foreign flavor, because obviously at normal rocket launches, usually you count down from like 20 or 30 or something. So maybe we get the long count. We'll see. To give you a little bit of idea of the scale of the rocket that you're looking at on screen, it's about 18 meters tall and 1.35 meters in diameter at the bottom. And you see it kind of gets a little bit wider halfway up the rocket. There it's at about 1.5 meters. So I don't know if you can tell based on the resolution of the screen, but it is a little bit narrower at the bottom. That's the core stage. So that's the first stage that's going to be burning that we're going to be able to see. The upper parts of the vehicle are a little bit wider, which is kind of a funky way to design a vehicle, because usually like it's more like the Apollo style where the widest stages are at the bottom. But you can actually make it this way and make it aerodynamically stable. You just have to have a rocket that vectors its thrust, which this one can do. So hopefully that's going to work out. And you're saying you hope it explodes? Come on. You got to give it good vibes. We want to see more rockets that can get to orbit. The more that go there, the cheaper it gets. And then we can put stuff into orbit for a bargain price, which is something that is always nice. I didn't know that it was a location where there's lots of comedians. But I guess that's cool. So we're just over 5 minutes away from launch now. We are getting into the final stages here. Don't be alarmed that there's no like gas clouds and stuff that you would normally see for filling of rockets on the rocket. This is a solid rocket, so it's just all solid fuel. it's fully fueled as soon as I set it up at the launch site. Yeah, all they have to do basically at this point is just fire the igniter, and then it should start. One disadvantage to solid rockets is that, of course, once you turn them on, you can't turn them off. So there's a little bit of a decrease in the controllability that you have. But they are a lot simpler, and they tend to be cheaper. So that's why Space One has chosen to go down this path of developing a totally solid rocket for Kairos in the end. But time will tell whether the strategy is actually a good one, and whether they're able to compete with the other small sat launchers that are in the market. Yeah, I guess if you don't really have a good reference, it could kind of look like a small a small rocket that amateurs would build. It does kind of have similar proportions, except an amateur rocket would definitely have fins on it. This one does not. And although it may look small, it is actually 18 meters tall. So that is not nothing. Like, that's, to put it in reference frame, like, that's like 4 stories tall. 4.5 stories tall. So it's not tiny. It's got a little bit of girth to it. It's 23 tons when it's all put together. So, you know, that's a pretty decent size. It's not it's not like huge though. Like, obviously, if you're comparing it to something like a Falcon 9, well, that thing's like 500 tons. So it's not that big, but 23 tons is still a lot, especially if you compare it to like amateur rockets and stuff. That's like probably usually on the order of 100 times bigger. So it just goes to show you the vast difference between building something that goes to space versus building something that is just going up a couple kilometers or so. Yeah, I know. It's tough that sometimes the news broadcasters are not so interested in showing the space stuff. But really, I think it's the most interesting thing. I mean, like, geez, like, something is going to space here. Why wouldn't they show that? And also, it's really awesome that Japan has actually so many companies that are actually developing rockets. So, I mean, that's kind of unique amongst countries in the world, I would say. To have so many vehicles that are currently able to get to space, that's a big plus. The V2 is bigger. Yeah, I think actually you're right. The V2 might have been bigger than this rocket. But the V2 definitely had more payload, and it was definitely way less efficient. Rockets have come a long way since 80 years ago. Oh, we have the count. They're counting right now. So you hear the lady counting in the background? She's counting down.
皆さんと一緒にこの瞬間を迎えれる。
もうぜひロケットが無事飛びましたら大きな拍手をお願いしたいと思います。
全然小鉄くん全然見てないやん。
We're 1 minute and 30 away from launch, so we're getting close here. And the countdown is getting me excited.
本番は10秒前から皆さん、10、9っていうのを一緒にやっていただきますんで。
I'm looking forward to the sounds. I think it's going to make a mighty roar. 1 minute away. Here we go.
30秒前にもう一回行きますんで。はい。おお、来た。
いよいよ1分を切ってまいりました。
さあ、来ましたよ。さあ、行くよ。さあ、来ました。さあ、夢の民間ロケット初号機。初号機。これからどんどん上がっていくという。ね。来た。さあ、行け。30秒前。
Only 30 seconds left. Once they light it, you can't unlight. Then it's going up or it's going up in flames. But hopefully, she'll get to space this time. First try. Can they make it?
それではカウントダウンをお願いいたします。
10、9、8、7、6、5、4、3、2、1。いけいけ
Okay, I think it didn't go.
頑張れさあどうだ
Okay, that's a weird one. It's just not firing.
来い頑張れ
Maybe the clock was wrong. I don't know.
いい風の時も
I don't know what all the numbers are.
頑張れ頑張れいけ
No, I think the igniter didn't go.
頑張れ
Shoot!
いけいけ
Yeah, I think that's a dud.
頑張れ
Now, theoretically, could they recycle? I mean, it is a solid rocket, so
どうだ
I like how they're keeping.
頑張れ
Maybe it could launch now. They do have a 1 hour launch window, so like in theory, they could launch any time in the next hour. But I think something's wrong. I think something's definitely wrong with the
11時17分
something's
12
wrong
秒
with the
に
igniter.
変更になりました
もう一回いいですか
いけるいける
Ah, that's too bad.
11時17分
I
12秒で
mean,
すもう一回行きましょう
11時17分12秒
if there's really something wrong with the igniter, it's not like they can go and fix it.
皆さん一回寝っ転がっていただい
Like
て
have like a guy run over, like check the.
一度
How's it working
次の
properly?
ということになりました。
でもまたもう3分ぐらいで
もちろ
Yeah,
ん希望
that's
を持ってください
definitely a situation where you gotta inspect the igniters. I mean, it could be just a software problem though too. So maybe it's just, you know, fix some code and away we go. But yeah, this is not looking good. They have reset the clock though. They reset it now for 14 minutes. So it could be that they're going to try to recycle. Again, like I said, they do have a full 1 hour launch window. So they have 57 minutes left to get this right. And looks like they reset the clock to 13 minutes. So I'm thinking that they're going to try again. I mean, what else are they going to do, right? I mean, surely the igniters work. Come on. That's like not something you'd expect to not work.
そうですね。もう改めてカウントダウンのね表示が変更となっております。あと13分10秒9秒ということでね。で
Yeah, without Werner von Braun, nothing works, huh? Yeah, he did have a knack for getting things to work properly, didn't he?
よかった
He definitely did.
あんなにね時間が決まった瞬間に皆さん
It's that German engineering, you know? It really adds a little bit of quality to the whole experience.
緊張しましたね。
That being said, Japan does actually have a pretty good track record with rockets.
になることがあるんですか
Like I said, a month ago, the H3 did launch, and it did launch fully successfully. So, who knows?
去年1年でね
Maybe this one still can be successful.
ね先ほどの先生にもあり
It's just working out the kinks, you know?
いや
いやもうでも人生でも一番ぐらい応援しましたね
Yeah, I'm curious if they're actually, like, if, I assume they're not going to send a guy out to check the igniter right now, because they're going to try to do it again in 12 minutes. But, I mean, if it doesn't work then I guess that's what you kind of got to do. And I wonder, like, how, like, that's kind of a tough job to have, you know? Being the guy who has to go and inspect the igniter. Hope nothing goes wrong.
来ていただかないと
They better give him hazard pay or something.
飛んでしまったのな
ねせっかくやったのに
Yeah, I'm not. I hope that they don't scrub completely.
したことない
Uh,
この感情というか
I think they still have a good chance to try to get off
3人
the
とも疲れてます
get off the,
今の
the,
疲れた
もう今のあそ
the
こ
launch
で
pad, you know.
今の疲れましたよ
ー11
Yeah, you can't really safe a solid fuel rocket. That's the problem, right? There's like an extra added element of danger whenever you're dealing with solids, because the fuel and the oxidizer are mixed. They're like together. So anything, if there's any sort of spark, any sort of thing like that, boom, you could set it all off. And you definitely don't want to be the guy inspecting it when that's going on. So yeah, it's that's one reason why liquid is always, a little bit, has a little bit more of a, extra safety added onto it,
いよいよまた残り10分。
10分にね、なろうかとしております。はい。
Yeah, it seems like the weather is all fine though. I mean, everything's looking pretty good. It's just something was wrong with the igniter. What else can we say? I wouldn't recommend it poking it with a stick. That would definitely be maybe not the best idea. The way to properly do it, if they have to go send somebody to inspect, they have to basically completely disconnect the igniter and disarm it. So remove any chance that they could accidentally send a signal that could accidentally ignite the motors, obviously. And then you have to be going there, you have to be very careful that you don't also create a spark or something that could ignite the propellant. And then you obviously have to do whatever work you have to do to try to see what's going on. But yeah, definitely a dangerous job, and one that has to be taken seriously. And there have to be operational procedures to make sure that things are going properly whenever you're dealing with solid rockets that don't ignite. Because another word for a solid rocket is just a bomb. And you don't want to turn the rocket into a bomb. That's not cool. Yeah, usually, yeah, for wind conditions on the launch site, like usually the wind condition at sea level is not really the important wind condition, because like think about it, this is a solid rocket. It has like some serious thrust, and it can thrust vector. So basically, no matter what wind you put at it at sea level, it's not going to outcompete the engine of the rocket. The winds that are up in the higher atmosphere are usually the ones that are more concerning, because they're quite a bit more vigorous. And sometimes, depending on like the thrust and weight of the vehicle and what actual like speed you get to, that is actually they can be more impactful and tougher for the engine to fight against, and also much harder for the structure to fight against those forces. Like when the wind is like 10-15 meters per second at ground level, which is quite a stiff breeze, that's like not really doing anything to the structure. But when you're flying at Mach 1.5 and you have a wind coming at you of 100 meters per second, obviously that has a bigger effect. Yeah, usually maiden flights are like this, there's little glitches, things that don't go exactly right, and then you're sitting on the launch pad, unfortunately, trying to figure out why things aren't working. For those who didn't catch it, just to get an idea of the dimensions of the rocket, it's 18 meters tall and 1.5 meters wide at the top and 1.35 meters wide at the bottom. So it is a large vehicle on human scales, but on like the scale of like comparing it to like a Falcon 9 or something, the Falcon 9 is 70 meters tall. So this thing would look like a little dwarf beside a heavy lift rocket. But that's not what it is. It's a small sat launcher, so it's pretty average on the small sat launcher scale. Like it's actually a little bit bigger than the Electron. But unfortunately, it doesn't quite get the same payload capacity. But that's just because the Electron is a liquid rocket, which is using liquid oxygen and RP1, which is a very efficient fuel combination, whereas this is using solid propellant, which is usually not quite getting the same specific impulse. So they have to have more fuel in order to do the same work, if that makes sense. But the trade-off that they get is sometimes solid rockets can be a bit simpler and easier to work with. until they don't ignite, and then it gets a bit annoying. But yeah, usually making them, you don't have to fuel anything, you don't need lines, you don't need tanks, you don't need anything like that. You just need a combustion chamber, and you got to mix the propellants into that combustion chamber, and away you go. So from an engineering perspective, it's simpler. Sometimes they're not simpler operationally. You want to know the dimensions in feet? Oh, American units. So yeah, 18 converts to about 60 feet, so 60 feet tall, and it's about 4 feet wide. Hopefully that is a better translation for all of my American viewers. Yeah, if the rocket falls over, that's a very bad situation. Because again, it's basically a bomb. I wonder if they're going to restart the count. I like the long countdown. It's a lot of fun. I also think I hope they resolve the issue. I hope it's just like a little software thing. That would definitely be better to see. We don't want another hold. Let's not jinx it, guys. Rockets are very superstitious, You can't give them bad energy. They don't want to go. I have to say the announcers are very excited. They're probably the most excited announcers that I've ever seen on a live stream before. Very passionate people. I have no idea what they're saying, but they're very into it. Yes, that's exactly the case. Rockets launch on their own schedule, right? You have to kind of, yeah, you gotta kind of, I don't know, gotta be calm. They can tell when you're anxious. Yeah, I would love to know what they're saying, to be honest. I would, but I think that we can kind of appreciate the energy. It's almost like watching Italian football. just by hearing the energy of the announcer, you get into it. So we're now just 3 minutes away from the next launch attempt. Again, we're in a 1 hour launch window here, and we've gone through the first 15 minutes of that. So they had a little bit of an ignition issue at the start of the launch window, and they didn't actually launch the rocket when it hit 0. So they recycled, put another 15 minutes on the clock, and they're going to try again. So we'll see if they can finally get those igniters working. Yeah. I'm hoping it's just like an electrical issue or like a software issue, and that they can easily work it out and just click the button and actually launch it this time. But we'll see. Again, it's good to sort of dampen your expectations a little bit, because this is the first launch of the Kairos vehicle, and it's Space One's first rocket they've ever developed. So if they're able to pull it off and launch this thing to orbit, that would be a huge success, because I don't think any other company has actually launched a rocket on their first try and gotten all the way to orbit. The countdown has started again. Let's go. 2 minutes away.
2分前でございます。
せーの。
I really love this countdown. It's like the best thing. We should have long countdowns for every rocket.
応援のメッセージきっとね、カイロスにも届いていると思います。ロケットですから。届いてます。届いてます。96、95、94、93、
まさかこんなところに立ち会わさせていただけるとは。
僕今トイレ行ったらあかんよね。びっくりするやろみんな。カウントダウンあるもんね。あと1分半。
All right, let's pray for a good igniter.
打ち上げまで1分です。走らないで大丈夫です。ゆっくりで。
I'm looking forward to what this flame's gonna look
さ
like.
あマックスのいただきましょうか。
行きましょう。
せーの。
It's probably got a pretty high thrust to weight ratio, so it's probably gonna take off pretty
30
quick
秒前
too.
から聞かせてください。大きな声お願いします。
ゆっくりで大丈夫よ。ゆっくりで。走らない。
30秒前からのカウントダウンでお願いします。それでは改めて私たちの夢を乗せて民間ロケット初カイロスまもなく発射です。
30 seconds. Here we go.
30、
29、28、27、25、24、23、22、21、20、19、18、17、16、15、14、
さあ行きますよ
12、11、10、9、8、7、
Here we go.
5、4、
Come on, igniters.
2、1、
いけ
ゼロ、いけ
Come on. Oh, why?
いけ
Hit the button. Hit the button.
来い来い
Oh man. Oh, this is too bad.
皆様
I guess it's better than it blowing up, though. They can always recover from this.
夢は続きますね
I have to say, this is
本
very
日
anticlimactic.
の発射は日程が変更となりました
はい
皆様に大変申し訳ございません
All
が
right, I
大
think
きな
it's time
拍手
for
お
the
願いし
igniter
ます
inspection. We gotta get the guy out who's gonna check out what the heck's going on down there.
応援していきたいと思いますいや本当に皆さん、
はい
ありがとうございました
ありがとうございましたわあ
They should just set up like a.
それだけ難しいことやっていうことですよ。
夢ある最高ですわ
They should just like set up a really long, like one of those really long like gunpowder ignition lines, so they can just have a guy just like light it with a match or something. That would be 100% guaranteed to work.
またですね、抽選会の方が12時30分から行われますので、皆さんもね、ゆっくりと
Well, maybe they'll try again.
ですね、一気に動くと大変危険ですので
I don't know.
ご注意いただきたいと思います。
さあそして次回ですね必ず飛びますんでこちらの
Seems like they might not be.
ご覧いただいて
I think they should try to recycle. They should try to try again another day, to be honest, because clearly something's wrong with the igniter.
改めての日程につきましては
I don't think they're gonna solve that problem anytime soon.
こちらの方でご確認ください。カイロスのロケット
But they do still have 40 minutes left in their launch window, so I guess they do still have a chance. But yeah, I think that the chances are going down, unfortunately. But at least the rocket is safe. I mean, it's still there, so no explosion. This is actually the same thing that happened to the H3 rocket last year. On its first attempt, it also had an issue with its igniters. The solid rockets didn't ignite, and then it also was stuck on the pad. So it seems like the Japanese rockets have a similar tendency to have issues with their solid igniters. What the heck are they doing? This seems like a very simple thing. I mean, how hard could it be to light a rocket? They probably have some crazy safety features in it that are, you know, messing around and causing issues here and there. But I'm sure they're gonna give it another try soon. Because I mean, how challenging can this problem be? It's just basically trying to figure out how the igniters work. But But it's cool to see so many people there. I mean, like there's like probably a couple hundred people there that are all gathered to watch this thing fly. So clearly there is a little bit of interest in the Japanese community and what's going on in their rocket launch market. Yeah, I'm not really sure which would be the next launch window that they will take. I assume it will be sometime in the near future, though. But don't quote me on that. They are kind of a not so how shall I say, showing everything to the public kind of a company. So it could be a while that they leave us hanging with not knowing what's going on with the rocket. Yeah.
打ち上げはなりませんでしたけれども、皆さんも引き続きこのロケットカイロスを応援していただきたいと思います。それではオンライン配信
Well,
の方は
I think we're gonna stick around for a little bit longer just to see if they do have any ideas about what they're gonna do. But yeah, scrubs are cheaper than Ruds. That's true. At least they didn't blow up the vehicle. Everything is safe. Everything's still on the launch pad. So they are able to go and check and see what's going on. Hopefully replace the igniter. Because it's quite clear that that's probably the issue. Yeah. In the end, you know, this is part of the rocket development process. So obviously there's going to be ups and downs. It's obviously quite difficult to try and make sure that everything goes right on the first try. Rockets are very complicated systems with many moving parts. Well, in this case, not so many moving parts because it is a solid rocket, but with many parts and systems, and getting everything just right is obviously a very difficult challenge. So, yeah, we wish better luck next time to the Space One team. I'm sure they're going to get it right. Japan again does have a very good reputation for rockets, so they usually do get it right quite quickly. So we hope that you can join us next time when we show off, hopefully, a successful Kairos launch. But in the meantime, thanks for joining. It's been really good having you guys here, and we're looking forward to hopefully streaming some stuff in the future. We're definitely going to do some other new and novel launch vehicles that are coming online this year. There's lots of them. So we're looking forward to showcasing those and hopefully sharing a little bit of interesting information about what's going on in the world of rocketry. In the meantime, remember to expand your horizons.